Alright, so in this video we're going to talk about measuring. Specifically, we're going to talk about how precise you should, how precise your measuring should be. And so the precision is actually based on the measuring tool. So a tool that's not as precise, obviously you won't be able to make a precise measurement. Something that is more precise, you'll be able to make a more precise measurement. So the rule is always measure to the estimated digit. And I should say to one estimated digit. So that's the rule. So let's just do these 4 examples, and then hopefully it'll make more sense. So here we're measuring, it looks like, to here, right? So this edge here, right? And so this looks between, this is 41 centimeters and 42 centimeters. But notice, we know for sure that this is 41.1, 41.2, 41.3, 44.4, here's 41.5, 41.6, 41.7. So to me, this looks like it's between 41.6 and 41.7. But what I want you to understand is 41.6 and 41.7 are exact measurements. How do we know that? Because there's marks for them. So I know this is going to be 41.6 something. None of these I am sure of 41.6, meaning I am sure to the 10th place that is 41.6 something, but I need an estimated digit. So the estimated digit is the one that I just kind of determine, estimate. I'm just going to say, let's say it's 41.63. And remember, you always measure to one estimated digit. Here's my one estimated digit. Don't forget my units. So 41.63 centimeters. Now, if I was grading this, I would know it has to be 41.6, right? Those are for sure. Why there are actual marks that go to the 10th place. But the 3 is an estimated digit, so it's kind of like your opinion, right? And so, in that case, 41.63 is the correct answer. I'm going to go out to the 100th place. The 100th place is my estimated digit. All right, let's take a look here. So I'm now looking at this is called a triple beam balance. So it measures mass. And why don't you try it? You can press pause and then try it out, and then I'll talk about it. So it looks like I have 20, and then this is 7.1, or let's try this 7.0, 7.1, 2, 3. So it looks like I go by tenths, right? And to me, it looks like it's right on 27.7. But if you look, the smallest the smallest mark is to the 10th place, so I know it's 27.7 something. To me, it looks like it's right on that line, the 0.7 line. So these 3 are exact. I need my estimated digit, so I'm just going to say I think it's exactly on there. That's my guess. I'm not going to use yellow. I'll use a different color. So I'm going to put 0. This is my estimated digit. And then this should be in grams. Okay, it's measuring the mass. So, once again, my 3, here are the digits I know for sure. I need to estimate one digit that was in orange. Okay, all right, here's some volume measurements. So I'm now looking at this one. Go ahead and try it out. So to me, I notice this goes by tenths. So I know that this, by the way, this is the bottom of the meniscus. We always measure the bottom of the meniscus. The meniscus, liquid because of its surface tension, and it's what we call intermolecular forces, make a meniscus, almost this rounded thing. So we always measure to the bottom. That's just what we've agreed on in science. And so I know it's 6.6 something, right? These are the numbers I'm assured of. Why? Because it goes to the 10th place. These are all 10th mark, right? And so I'm going to say it's 0, and then this is probably in milliliters. Let's take a look. Why don't you give this one a try, this next one. So the smallest interval here is the ones, because this is 41, 42, 43, 44, 45. So this is between 44 and 45. So it's 44 point something, right? This I know for sure. I need to estimate the next place over, so I'm going to say 44.8 milliliters. All right. Hopefully that helps. If you look at, let's take a look. If you look at this slide down here, it's pretty cool because it gives you more practice, and it also provides the key. And so the key kind of gives you an opportunity to practice and also check your answer. Okay? All right, hope that helps.